Welcome to this course on Elements of Mechanical Engineering. My name is Atchuta Ramacharyulu and I am working as an assistant professor in the Department of Mechanical Engineering. In this lecture, we are going to see different welding techniques which are used in manufacturing industry. In the previous lectures, we have seen some of the welding techniques like soldering, brazing and some other techniques like gas tungsten, arc welding, etc. In this lecture, we are going to see the remaining welding processes which are used in engineering field. So, the first technique for today is plasma arc welding. So, what is plasma arc welding? So, this is a kind of welding which is done on metals. This is very similar to gas tungsten arc welding, that is GTAW, where we are going to use some kind of different energy source. In GTAW, we will use the heat source as the electricity. Electricity will be used for the production of arc. Whereas in plasma arc welding, we are going to actually produce a plasma arc. This plasma arc is produced from an electrode which is surrounded by a shielding gas. Due to the presence of this shielding gas around the electrode, we can see or we can observe the formation of the plasma. So, the process is very similar to gas tungsten arc welding, GTAW. The arc is formed in this welding is plasma arc. Generally, in GTAW, the arc formed temporarily will be called as plasma. It is only plasma for only a few moments of time. But in plasma arc welding, the arc formed itself will be plasma only. So, the entire process we can produce a constant flame of plasma arc. Why? Why do we need this plasma arc welding? So, this plasma arc welding can reach up to a higher temperature of about it can reach a temperature of about 28,000 degrees centigrade. Because of this high temperature, when compared to normal welding, this temperature is possible to melt many hard metals. Whereas in GTAW, the maximum temperature that can be reached is 5,500 degrees centigrade, which is far less than the 28,000 degrees centigrade. That is why plasma arc welding is widely used in most of the engineering applications where it has more melting capacity. It can melt thicker metal plates than normal welding. So that is why plasma arc weldings are used where precision is required as well as to melt thicker plates depending on the application. And then in this welding, the arc is formed between the electrode and the workpiece. So there is a picture in this slide where we can observe the different parts of a plasma arc welding torch. First one is gas plasma. So this is gas plasma where some gas is sent into this torch in order to produce plasma arc. And then inside that we have this part is called the fourth one. It is called the electrode. So we can see clearly the electrode is completely surrounded by the plasma gas. When it is ignited, we can see the formation of plasma arc, which is orange color and red color here. So this is all the plasma arc. And then we have second part, that is nozzle protection. This entire thing is nozzle protection in order to protect the electrode and the plasma from external shocks and heat. We have to cover this with nozzle protection. And then third thing is we have shielding gas. So here we have a separate opening, slit opening is there, through which we can make the shielding gas to flow through the torch. So what is the purpose of this shield gas? So shield gas, plasma gas, both are different. Plasma gas is used to produce the arc, whereas shield gas is sent into the torch in order to avoid the oxidation of the freshly welded joint. So whenever this plasma arc, it produces high amount of heat. It will make the metal melt. So the metals will be melted at this high temperature. So in order to avoid oxidation, we have to protect this by using some kind of gas. We might be using some inert gases like helium, neon, etc. So these inert gases will it will stop the oxidation of the freshly welded joint. So the third important point about this electrode is, in this welding, the electrode is placed inside the torch. That means it will not be in contact with the shielding gas, okay, which is a disadvantage in case of GTAW. So mostly we will compare this welding with the GTAW. So the disadvantages or the shortcomings that we have seen in GTAW have been rectified and modified. Finally, we got this plasma arc welding. First thing is low temperature. The GTAW has low temperature. And then second one is the electrode will come in contact with the shielding gases in case of GTAW. Electrode contact. Here the contact will not be there. And then third point is we can produce more temperatures. Okay. So these are some of the shortcomings that we have seen in the GTAW, which have been rectified, and we have formed plasma arc welding. So we are going to use some kind of plasma gas in order to produce arc. This arc is so hot that it can melt and it can reach up to a temperature of 28,000 degrees centigrade. Here, the plasma is forced through a fine bore copper nozzle which consists of the arc. See here, we have a nozzle. This place contains a nozzle which will make the plasma or the gas that is coming out of the torch to come out with a higher velocity. So that is why we have fifth part. This is nozzle constriction. So nozzle constriction is the area where the area of the nozzle will be reduced so that the plasma that is coming out of the torch will travel more fastly. Okay, and then we have, so these are all the basic parts of a plasma arc welding torch. Now let us see what are the classifications of plasma arc welding. In plasma arc welding there are two types. First one is transferred arc method. So in transferred arc method, the workpiece will be a part of the circuit. See here, we have these two pictures here. Okay, the first picture is transferred arc method, where we can see clearly the power supply is connected between the electrode in the torch and the workpiece. So this is workpiece and this is electrode. The power supply will be done between the electrode and the workpiece. So the workpiece usually will be positive and the electrode will be negative, so that we can make the flow of electricity through this plasma arc welding torch. So this is transferred arc method, whereas in second method, that is non-transferred arc method, we have the same figure here. Here the second figure showing that the workpiece is not a part of this circuit. So the workpiece is separately placed and the positive and negative poles of the torch will be connected to the torch itself. That means it is connected to the nozzle. See here, this electrode is connected, this is negative, and the positive pole that is connected to the nozzle itself. So that due to this flow of electricity between this nozzle and the electrode, we can see the formation of plasma arc. So using this plasma arc, we can directly make or we can directly weld any kind of metal plates without having the knowledge of the metal plate should be highly electric conductance. Okay, without electric conductance also we can make or we can create heat from this plasma arc welding, that is through non-transfer method. Whereas in transfer method, the metal plate should be highly electrical conductivity so that the electricity will flow through the plate and it will form the plasma arc. So this is the difference between transferred arc method and second one, non-transferred arc method. So in transferred arc method, the workpiece will be it is a part of the circuit, whereas in non-transferred method, it is not a part of the circuit, it is separately placed. The positive and negative poles are connected directly to the electrode and the nozzle respectively. And then let us see what are the different equipments required for plasma arc welding to be done. There are like multiple equipment required. First one is current and gas decay control. We need current obviously because we have to make power supply into the electrode so that the circuit will be closed, so that we can make the flow of electricity. With the flow of electricity, we can produce arc by combination with some plasma gas. So it is required to close the keyhole properly while terminating the weld in structure. So in order to make the current flow through the circuit, we have to make sure that the key is properly switched on so that the electricity will flow through the circuit. And then second one is fixture. Fixture is nothing but it is a device required to avoid atmospheric contaminations of the molten metal under bed. So this is a holding device on which we can place the workpiece, and it has to be so strong that it has to hold the workpiece and it has to avoid the atmospheric contamination of the workpiece also. And then we have materials like steel, aluminum and other materials are required in order to make them use as a filler metal. We know in welding we have to use some kind of filler metal. So in this we have to use steel, aluminum and other metals for filling. And then we have high frequency generator current limiting resistors. So what is the purpose of this high frequency generator and current limiting resistors? So this is used for arc ignition. Okay, the arc starting systems may be separate or built into the system. So whenever we want to switch on a plasma arc welding torch, we have to make sure that these high frequency generators are connected to the electrode. So whenever this high frequency generator sends a current pulse, it will form a spark. This spark is used to produce an electricity. That means it is used to produce the plasma. So the next device is plasma torch. This is all we know. It is used for the transferred or non-transferred arc type. It is hand operator sometimes, or it is mechanized. So the hand torch with which we can hold the hand torch through which the plasma arc will be produced. And then we have power supply. So a direct current power source having a voltage of 70 volts or above is suitable for plasma arc welding. So this plasma arc welding requires about 70 volts of electricity. Okay, it needs this voltage in order to produce a proper plasma arc. And then we should need shielding gases. Different gases are used, like inert gases will be used in order to shield the joint to prevent it from contamination with atmospheric oxygen. And then we have voltage control also. Depending on the thickness of the plate, we have to change the voltage so that we can weld the required plates of thickness. So these are all the important equipments required for plasma arc welding. And then we have some more important points regarding the plasma arc welding. Compared with the other arc welding processes, plasma arc welding has better arc stability and less thermal distortion. So in this we have a continuously produced plasma arc, which is more suitable for welding longer areas, and higher energy concentrations is also present, thus permitting deeper and narrower welds. So this will make to form deeper and narrower welds. Depending on the type of application of the welding, we can use this plasma arc welding by changing the voltage. In addition, higher welding speeds are possible. 120 to 1000 millimeters per minute. It can be used to weld this much of length per minute, 120 mm to 1000 mm. And a variety of metals can be welded with part thickness generally less than 6 mm. So whenever the thickness of the plate is less than 6 mm, we can weld wide variety of metals. If it is more than 6 mm, we have to limit to a certain metals like iron. And then a typical temperature value, we have seen this already. The temperature, it will reach about 28,000 degrees centigrade, which is about 50,400 Fahrenheit, compared to 5,500 degrees centigrade in ordinary welding process, that is GTAW. So this high temperature capability will make the plasma arc welding very suitable for most of the engineering applications. It is smooth. The process of welding this using the arc welding is very smooth, and it can reach higher temperatures also. And then, so that is all about plasma arc welding. Then we have the next technique, that is arc welding process, which is consumable electrode type. So in this we are going to study SMAW, that is shielded metal arc welding. So in shielded metal arc welding, we need a power source, and then we should need some working cables, and then we have electrode. So, and generally workpiece will be there. So what happens is, one pole of the transformer or the power source is connected to the workpiece, and the second one is obviously connected to the electrode. So whenever I touch the electrode to the workpiece, it will form a closed circuit. See, observe carefully. Whenever I touch the workpiece with the electrode will be like this. Long metallic rods will be there, which are coated with some kind of metal. And when this electrode, when it is fitted in the torch and it is touched the workpiece, we can see the formation of a closed circuit. We don't see the formation of arc. So whenever the circuit is closed, the electricity will be flowing through the workpiece. So this is not required. We have to produce arc in order to weld. So what do? We have to remove the workpiece. We have to remove the electrode slightly away from the workpiece. Okay. So in this picture we can see the workpiece and the electrode are not in contact. They are slightly away from each other. In this picture also we can see they are slightly away from each other. Okay. They are not in complete contact. So what happens when I touch the workpiece with electrode and I move little farther, then it will form a resistance. Air inside, air between the workpiece and the electrode will form resistance to the flow of electricity. This resistance will create a spark. Okay. Generally, if there is any resistance in a body for the flow of electricity, it will form some kind of sparks. Okay. So we are using the same concept in welding. So we have to touch the metal workpiece with the electrode and we have to slightly move it further so that it will form a air resistance in between these two. So here air will be there, it will form some resistance. Due to the resistance of the air, the spark or the arc will be formed, and this arc rises a higher temperature of about 6,000 degrees centigrade. And due to this heat, we can actually melt the workpiece as well as the filler metal if it is separately used, or we can directly use the consumable electrode, which is filler metal itself. So this electrode, this is filler itself. So whenever we are doing welding, this electrode will be consumed while it will form a layer on the base plates. So this is all how the arc welding process is done. That is submerged shielded metal arc welding. So here we have to shield the entire thing, like the newly welded joint and the electrode, everything will be shielded with the help of a gas. So these gases are generally inert gases. So what happens when we shield them? So in order to avoid oxidation of the newly formed joint, we have to shield this entire process. So we have to flow some gases on them in order to avoid shear oxidation. So why do we need to avoid oxidation? Because in order to stop the oxidation, what are the bad effects of oxidation? So oxidation makes the joint very weaker, which is not required at all. We have to make the joint as strong as the base metal. So in order to do that, we have to make the joint so strong that it will be as same as the base metal. Suppose I am joining two metals, two plates. If I do welding here, the welding joint should not be as weak. It has to be as strong as the base metal. If this metal is strong, the both plates 1 and 2 are stronger. Now I have to form a joint which is stronger, as stronger as the base metals. So see this. This is how the electric arc welding of consumable type will be done. And then the heat generated melts a portion of the electrode tip and its coating. So whatever the electrode is there, we are using in this process, it is coated with some kind of coating which is made up of metal. So this will melt and it will form a layer on the base plates. And then the electrodes coating deoxidizes the welding area also. So whatever the coating that is present on the electrode, it will deoxidize the area of weld. So the electrodes are in shapes of thin, long rod ends. This process is also known as stick welding. So this process is also called as stick welding because of the shape of the electrode. So almost all the electrodes are very long and thin in size. So what are the advantages of this process? This is very simple. Any person can do with a little practice, and it is versatile. It can be used in any place and it can be used for welding at any elevation. Like for a 1,000-story building up, we can do welding there also, and requiring a smaller variety of electrodes. Depending on the metal, base metal, we have to choose a particular electrode, and it requires the same kind of electrode for almost all iron types. If we want to weld other metals like aluminum, we have to change the electrode. For almost all iron related or ferrous metals, we have to use the same electrode, because iron is very widely used. So we should always go for iron filler rods. So let us see what are the applications of this shielded arc welding process. So general constructions, in almost all the constructions this is used. Shipbuilding industry, pipelines and maintenance works. So all these purposes, the welding process is very suitable. And then it is especially useful for work in remote areas where a portable fuel generator can be used as the power supply. So depending on the type of power supply available at the area, like in oceans, we have oil rigs where the oil from the ocean bed will be pumped out. At those places, they cannot have a constant power lines because they are situated out there in the deep sea. So at these locations, they have to use a very limited power source. At those places, they can use this small welding machines which are very portable, and they can do welding method. Okay. And then SMAW, that is shielded metal arc welding, is best suited for workpieces of thickness between 3 to 19 mm. So up to 19 mm of thickness plates can be welded easily with this SMAW. So the solid part slag can cause severe corrosion of the weld area and lead to failure of the weld, which is removed by wire brushing or weld chipping. So whenever I weld a metal plate, if two metal plates are welded, we can see the formation of this slag. So what is the disadvantage of this slag? We can see this slag is somewhat oxidized. Even though it is shielded, we have to remove this slag in order to avoid further corrosion. So the two base plates are joined. Even though upon these two plates joined, we can see the formation of some slag. This slag has to be removed in order to avoid the oxidation or corrosion of the actual joint. Okay, so it will be removed simply with the help of a wire brush or with wide chipping. Chipping hammer will be there. We can chip this and we have to remove this so that it will be formed neatly. And then we have another technique called submerged arc welding. So submerged arc welding is very similar to the shielded metal arc welding. That means we have to submerge the entire weld base plates under a flux. So what is a flux metal? So flux is a powder kind of material which is used to cover the weld joint in order to prevent it from oxidation. But this process requires a very high skill, because without looking at the actual joint, we have to do welding. Okay, so this is called submerged arc welding. This is suitable for some other processes or some other applications where a skill is also required. So in this method, the weld is completely submerged under flux like lime, silica, manganese oxide, calcium fluoride, and other components. So these are the most widely used flux materials, and the flux is fed into the weld zone from a hopper by gravity flow through a nozzle. So a hopper is arranged at the joint where we have to do welding. So whenever we are doing welding, the powder or the flux particles will be flown onto the welding joint. Okay, and it prevents spatter and sparks, suppresses the intense ultraviolet radiation, and few characteristics of the SMAW process. So whenever we are doing SMAW, shielded metal arc welding, we have to experience ultraviolet sparks that are coming from the electric arc, and also some harmful gases will be emitted. So all these gases and spark ultraviolet lighting can be prevented by the flux. So whenever we are doing welding, we have to flow the flux particles. So flux is a powder. We have to drop the powder through a hopper. So by doing this, we can avoid the ultraviolet rays that are coming from the. We can. These ultraviolet rays are very harmful for human eyes. So that is why they have to be protected. So by using the flux, we can protect the light and also the gases. The flux also acts as thermal insulator by promoting deep penetration of heat into the workpiece. So this flux material also it will protect the or it will insulate the temperature. So whenever we are doing welding, we require very less amount of heat for the welding process to melt the base plate and filler rod. So that because of this insulation, we can do this welding process very fastly. And the unused flux can be recovered and it can be reused. So whatever the flux powder is there, after welding we can remove that and we can reuse it after a proper treatment. The consumable electrode is a coil of bare round wire which is 1.5 to 10 mm in diameter depending on the application. It is fed automatically through a tube. Electric current typically ranges from 300 to 2000 amperes. So we can see this is the process of submerged arc welding. Here we can see this is a hopper through which we can make the flux to flow into the weld joint. And here we have, this is the electrode or the filler material which is fed into the welding torch. And then here we have the actual welding machine where we can make the electricity to flow into the workpiece. So whenever the workpiece is fixed here, the tool will be moving from this point to this point, that is in this direction. So we can see whenever we are welding the area, at the same time we can see the flow of this flux material onto the joint, so that we can insulate the joint, we can insulate ultraviolet rays, we can insulate harmful gases, and we can make the joint so fast because of the insulating capacity, which will make the plate to retain the heat more time. Okay, so these are some of the advantages of submerged arc welding. So this is used for carbon and alloy steels and stainless steel sheets of as high as 5 mm per minute. And the quality of the weld is very high with good toughness, ductility, and uniform properties, because we are completely shielding the weld with this flux powder. And the SAW process provides very high welding productivity, depositing 4 to 10 times the amount of weld metal as per the SMWA process. So in this process, we can do more fastly. The welding can be done more rapidly because of the insulating capacity of the flux material. Because the same tool which we are using in SAW, that is the shielded arc welding process, SAW, there we have to use a simple electrode only. There the temperature will be in contact with the atmosphere, so that it will be cooled fastly. But here we are using a flux material which will make the temperature to retain for a longer time, so that we can do this welding very fastly. And the typical applications include thick plate welding for shipbuilding and for pressure vessels. So at these applications, this submerged arc welding is very useful, and this process requires high skill and it requires more time. And then we have gas metal arc welding, GMAW. So this process is also very similar to the electric arc welding, where in this process we have to use some kind of gas to protect the fleshly made joint. So the weld area is shielded by effectively inert atmospheric of argon, helium, carbon dioxide or various other gas mixtures, where we can stop the oxidation of the base plate or the freshly made joint. And then we have this circuit. The circuit will let you know that this is very similar to electric arc welding, where we have an extra device that is this shielding gas. So this shielding gas is connected to the electric torch, where it is while it is producing a electric arc, it will also make the gas to flow into the workpiece. Okay. So this is in addition to using inert shielding gases, deoxidizers usually are present in the electrode metal itself in order to prevent oxidation of the molten weld puddle. So you may get a doubt that GMAW is gas metal arc welding, and then previously we have seen in the previous lectures, that is TIG. What is the difference between these two methods? So in TIG, we have an electrode which is non-consumable electrode, whereas in GMAW this is a consumable electrode. Okay, so that is the basic difference. In TIG, tungsten inert gas welding, tungsten is a non-consumable electrode and we have to use a separate filler metal, whereas in gas metal arc welding, the electrode itself is a filler metal which can be deposited on the workpiece, and at the same time we can flow inert gases in order to avoid oxidation. And let us see some important properties of this GMAW. The temperatures generated in GMAW are relatively low. Consequently, this method is suitable only for thin sheets of thickness less than 6 mm. So this process is very slow because we have to make the air flow, and at the same time we have to make the electrode which is consumable. So this is very slow process. So we have to do this welding very slowly. In order to use this process, we should always go for thin sheets and sections which are less than 6 mm. And the operation which is easy to perform is commonly used for welding ferrous metals in thin sections only. So this is mostly suitable for ferrous metals only. So which makes it very less versatile. And this process is versatile, rapid and economical in welding. Productivity is double than that of SMAW. So overall productivity is more, but we can weld only thin sheets. So these thin sheets cannot be welded by using SMAW. That is why we should go for this GMAW. And this GMAW process can be automated easily and lends itself readily to the robotics, to flexible manufacturing systems. So this process can be directly installed with a robotic hand, and where it can be automated, so that it will take very less time, because this is a very slow process. That is why we have to use robots to improve the efficiency and precision. So that is all for this lecture. So far in this lecture we have seen different types of welding techniques like shielded arc welding, shielded metal arc welding, gas arc welding, plasma arc welding. So we'll meet in the next lecture. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.